I said 3 views. I said, ooh, that motherfucker.
Yeah, I mean, it's an educational video thing specifically for this class. It's not like there's 1,000 people going to watch it, but it's there if you need it. Alright, so there's that summary. Hopefully you have all that information down. I will try to get these slides uploaded later today, but here's our agenda for today. We're going to look at the objectives from 1.11. We're going to relaunch 1.11 before y'all work in some small groups. We only have about 25 minutes left in today's class, but hopefully that Venn diagram was useful and will help us. Sir?
Going by fast. Since the whole day been going by fast, and everybody.
So let's get started with today. We'll just do a few more. Whatever we don't get through today in 1.11, that's what your homework is. So I would get as much done today in your small group as possible.
Going for accuracy.
Say again?
Going for accuracy.
We'll see. First objective. Linnea, can you read this first objective out loud for us?
I can identify sequences through their rates of change and vice versa.
So we want to be able to identify sequences through the rates of change and vice versa, meaning I can identify rates of change based on their sequence. Alright, McKay, can you read us our second objective?
I can create multiple mathematical representations for sequences. Specifically, I can write a recursive and explicit equation for a sequence.
Yeah, please notice I want to create multiple mathematical representations. Each representation reveals something new. What are the different mathematical representations that are available to us? Tabular, so tables. Pictorial, or pictures. Verbal, algebraic. That's the type of sequence. And graphical, right? So all 5 of those representations can reveal new bits of information, right? The verbal or the words, algebraic or your equations, your expressions, all those things. These are all different representations, and we want to use the other 4 really to help us get to this point of being able to write recursive and explicit equations. This is an algebraic connections course, so we're trying to see the connections between all the different representations and algebra, which is how we write equations and expressions with variables. So in each of the problems below, some information is shared with you about a sequence, and you need to identify everything else that you can, right? So tables, graphs, explicit, recursive equations, constant ratios or constant difference. Remember, that's just common ratios and common difference. Maybe terms that are missing, type of sequence, etc. We finished through number 6 before the exam, correct? So we only have 7, 8, and 10 left, because number 9 they messed up on, so we're just not going to stress about it. So within your groups, actually first off, I'm going to just ask a couple of quick questions and I'll let you work in your groups. What are some initial things that we should notice about number 7? Based on the wording that is there, what should we automatically be like, hey, I know this?
Ratio.
Constant ratio, why is that important?
Because
Geometric.
That tells me it's geometric, because we are repeatedly what? Multiplying by... Okay, but what are we multiplying by? By -2. Right? Notice we have a rate of change. We also have a starting point. You need to create at least 4 different things for this sequence. We've already got one. It's geometric. We already know that. We can make tables, we can make graphs, we can make whatever we want, but I definitely want you to be thinking about recursive and explicit equations, because those are the things that we really have to work on. We all clear on that? We good? Ready to work? Alright, let's knock out as many as we can. Yeah, hold on one second. Let me pause the recording.